Alright, welcome back. So here we are in the lecture for Module 9. And as I said in the overview, we're going to deal with a couple of things. We'll start off with AI software. Now, when it comes to software, there's so much that can come into play when we're talking about software as it relates to AI, because we've got to think about the different levels of the system itself. The computer we're working on, well, I could have software there. I may connect to a cloud computer or a server somewhere. There's going to be software there. Am I going to deal with cloud software? What kinds of software are we talking about? And if we're looking at it from the perspective of AI solutions, or we'll dig a little bit deeper, ML solutions, machine learning solutions, or deep learning solutions, or NLP, natural language processing solutions. These will require more software to develop the solution itself. So, we noted before, the predominant programming language that's being used, and that we'll use in subsequent courses, is Python. And Python software, and there may be libraries that we would need to use that would tie to specific platforms, if you will. So I can have third-party software that I can connect to my solution using APIs, and that's all run through Python programming, and we've got different libraries available to us. It could be a library on the kernel of the system itself. It could be a library that I've imported that's a Python library, whether it's Keras, TensorFlow. There's so many different libraries that as we move forward, you become familiar with more and more libraries. And we've talked about some along the way up to now. I've tried not to dig into the programming aspect of it, but it keeps coming up, glimpses of it here and there. Okay. So when we talk about software, these are the kinds of things that are coming into play. And they all run on the hardware that we've talked about in the previous module. So these variety of libraries and frameworks that we have available to us, they're something that somebody else has created. We'll call them frameworks, classes of code, libraries, and within them we've got functionality to perform tasks. We can create clones or duplicates, instances of this code. I don't need to recreate it. I can just copy it, call it whatever I want to call it, and use it. Okay. Now, there's a variety, as I said, of different frameworks available to us. And the different frameworks may use a variety of different sub-libraries. So let's say somebody creates a framework. This framework is not just one library. It could connect to, let's say, half a dozen or a dozen different libraries. It's like a one-stop shop for everything you need to complete this specific task. And here they talk about the Intel Math Kernel Library. All right. It's designed specifically for deep learning, but it connects to a variety of different other libraries, okay, to ultimately create a framework. Now, as I said, we've got different languages we can use, whether we're using C, C++, Python, Java. It all depends on, we go with what we know. If I've been trained in a certain language, then that's the language I use. If the shop I'm working in uses a specific language, that's the language I'm using. Right? So when we look at what language do I want to take, what courses do I want to take, and using what language, I need to look down the road. What kind of job am I going to get? What are they going to be using so that I have the tools I need to be able to do what I need to do? We talked about AlexNet in previous modules. Right? We talked about deep learning in different modules. And over time, we've talked about how the capacity of computing has evolved over time. So when it comes to software, there's so much going on. This is something that is changing, evolving monthly, daily. So we've got to stay in tune with what's happening. Here's examples of a variety of different Python packages that we can use. Most of these you will use in subsequent courses in the AI program. Commonly used libraries. NumPy, mathematical library. We talked about data types before. NumPy allows us to add another data type to our repertoire, list of things that we have available to us to use. More data types, all right, it's like more tools in our tool belt, if you will. Okay. So I've got this slideshow available to you in that same lecture area of the course. It just goes through different libraries available. TensorFlow, very common library, talks about the hardware requirements. We're not going to dig that deep into this. Keep in mind, this is that 10,000 foot view course. Now, one thing I want us to talk about is NLP. I already told you that I've got a couple of good references for you when it comes to NLP and hardware. Right, so there's some good resources there. As we go through this, and I talked about Dragon Naturally Speaking and how long ago that was on the market. Now, we talked earlier about how long AI's been around. We're looking at around 70 years. So it took about 35 years, half the time, for it to come up with some kind of marketable NLP solution. I talked about in the overview that NLP is not just spoken word, it's text words. It doesn't even necessarily have to be words. It could be sign language. So a variety of different things that we're doing. It's a communication tool. The variety of different languages. Now, when we think about different languages, we may want to think about the different dialects of a language. And can that be a hurdle when it comes to, or a challenge when it comes to natural language processing? Absolutely. As time has evolved, the data set that NLP has available to us has grown. Much like there's an MNIST, M-N-I-S-T data set that is part of NLP. It's a character recognition data set. So it's handwritten letters, and we can use deep learning to interpret what somebody has written by hand. And they've had a vast number of people write numbers. All right. So these different numbers, we don't all write the number 1 the same, or the number 9 the same, or the number 6 the same. Some people may write more like cursive. Some people may write more like block letters. That same kind of differentiation between the personalization of writing comes into play in the personalization of spoken languages or spoken word. It's a big hurdle, or as I said, big challenge. Slang. One word meaning a variety of different things. Contextual meanings. These are all different hurdles that we may hit, or the systems have hit along the way. Now, AI, specifically deep learning or natural language processing, NLP, is currently being used to translate languages. You can have somebody speak into an app and it will type out what they said in a different language. We see law enforcement using it quite often. One of the things that we've got to do when we're dealing with NLP is to clean and pre-process the data. And if you think back to the IRIS data set and what took place back then, we had 4 features, 3 classes, and a total of 5 columns, 1 for each feature and 1 for the class. Now, we're dealing with words, and essentially we need to kind of label the words to give them some context or meaning. And this is called tokenization. And what we essentially do is take the word and we tokenize it. Is it a verb, adverb, noun? What's it mean? How can we label that? So we've tokenized a sentence that says John ate 4 cupcakes, period. Each one of those words is tokenized, so there is some classification, if you will, associated with the word. Now, based on that, we can identify the end of a sentence, punctuation. So see how this tokenization, has enabled us to interpret a sequence of words, or words and characters. This is just text. Same kind of thing comes into play when we're talking about spoken word or audio. It's a little more difficult. We have the ability to do stemming, and stemming describes how we go through and we have a word, but you may have seen it in the spelling bee, where the individual going up trying to spell the words, is this the root of consult? Consulting, consultant, consultants. So the root is consult. So we call this stemming, breaking it down to the root word. Excuse me. We've got other aspects of NLP. Lemmatization, and it's kind of similar to stemming. We're not looking for the root. We're looking for, we're dealing with verbs, or adverbs. Let's say am, are, is, they're related to be. So there's so much that comes into play. This kind of explains why it took 35 years for this to get rolled out to become a thing, even though after 35 years it was still not reliable to use on a widespread basis. But as hardware got better, as the capacity of computing got better, as we got into deep learning, think back to chapter 4. That allowed us to be more effective and higher accuracy when it comes to NLP. So I said it's not just text, it's voice. And you talk about the difference between formal language and the real world language. And that's one of the things that if I had ChatGPT create a paper for me, ChatGPT is not going to use slang. It's not going to use real language, real world language. It's going to use a formal, more of a computer version of it. When you read it, it just doesn't read right or may not sound right. With the deep fakes, where they would have somebody, they would feed it text, and then we have NLP convert that text into audio. Oftentimes we can recognize that this is AI, a deep fake. It's not real because of the pronunciation. Things that we may say as an abbreviation, AI doesn't realize it's an abbreviation and it tries to pronounce it. So we still have a ways to go before this is as close as it needs to be, but it's getting really, really good when it comes to the effectiveness of NLP. So we've got so much available to us. Things are evolving at such a fast pace. Folks are trying to make money, be profitable using these new tools and resources. Maybe not always for the good. You know what I mean when I say for the good. And maybe for the good of their bank account, but not for the good of anything else. So keep that in mind. And as you're going through the different videos and other resources relative to this module, you're going to have a paper, at least I think 2 more papers before the course is over. And your perspective on these things, the more you know about these things, the better you'll be able to respond with your perspective in those papers. Okay. So as you find resources, document them. You may need them in the future. Keep track of those URLs, the resources you've used along the way. Okay. We've all dealt with chatbots, whether it's over the phone or if it's on a computer. And the future of NLP, man, from the time this was written, which wasn't that long ago, NLP has already changed. Okay. So keep this in mind. Like I said, we're still here in Module 9. And in this module, we've just got those 2 things to knock out, the discussion and the reflection. So as I said in the overview, look ahead to 10, look ahead to 11. See what it is that you're going to have to write on. Things that you hear about, things you find along the way can help you out a great deal when you deal with those papers in the future modules. Okay? Always be planning ahead. So we'll see you in the next module.